Yeah, so they were saying the main difficulty is to think of including the extra two nodes plus or minus 1 and evaluating the coefficient of n plus 1. When n plus 1 is higher than the degree of f, it is possible to solve the problem using Lagrange interpolation on the nodes x1 to xn, but the definition of the polynomial being interpolated should depend on the parity of n. For n even, consider the polynomial blah. So it's actually pretty complicated to come up with that. Okay, so solution 2, according to the shortlist, was observe G is symmetric in the variables blah. Define V. Let's see, so G is symmetric in variables. Define V equals product I less than J. X J minus XI. It's like it's backwards. So then F equals, let F equals G times V. So you clear out the denominator. You clear out the denominator. So F is a polynomial. Since V is alternating, F is also alternating. Every alternating polynomial vanishes when any two variables are equal, and is therefore divisible by xi minus xj. Wow, that's pretty cool. Okay, so this is basically the denominator, yeah? So that's a pretty nice argument, I guess. So this is a polynomial. So this is the thing from the question. So if you clear the denominators, you get a polynomial. So was the original polynomial clearly symmetric? We swap two of them. Was the original thing obviously symmetric? What was it? Sum of I, product of J equals I. Is that obviously symmetric? Do you want to swap I with like something, for example? What do you get? Hmm. Hmm. Okay, so let's imagine swapping two values like xk swaps with xl. What happens? So when I equals k and when I equals j, there's definitely something affected. All the other ones, we won't care. I think this will only change things when I equals j or k. So it only affects these two terms. So product of j not equal to k 1 minus xk xj and plus. Yeah, so the thing about it's kind of weird because I feel like the shortlist problems, they might still not be that great because that's why they didn't make it to the actual test, but they could still be good. I mean, I guess they're still used on the TST, so yeah. Um, yeah, so and I guess it's much better going through a solution once you've tried it, and probably even better after you've solved it. So here you have the other one is not equal to L, yeah? So that's an L. This is XL minus XJ. Okay, you say it's pretty sure it's symmetric. So what happens? Well, if you swap them, I guess you're just swapping these two terms, right? Not quite. Not quite. Because you're getting something a little bit different, okay? It's not what it is. So let me just erase this. Uh, so what do you get if you swap it? You get not quite exactly that, okay? There's gonna be an extra j is not equal to. So I'm pretty sure the part that's j is not equal to k or l is the same. They just swap to each other. Yeah. But you do get like a 1 on, you do get a 1 minus xl squared. Yeah. And on the bottom you get xl minus, oh, that doesn't work. xl minus xl. Oh no, that's swapped as well. Okay, so it is actually the same. So when k goes to L, the other L that was there went to K. Yeah. Okay, so it's actually like it is true. So it is they just swap to each other. Okay, so this is symmetric. And V is alternating. So this is alternating. So what does alternating mean? It means instead of just being symmetric, it changes sign. according to the sign of the permutation. So if you just swap two variables, it'll huh. Now I'm getting confused. If it's just a transposition, yeah, between two variables, it should just be a negative one. So every time you swap one of them, it's out of order. It puts it out of order. How do we show it's alternating? So how do we show that V is alternating? So let's say we swap xk with xl. So everything's unchanged. It doesn't have a k or an l in it. So we have to consider what happens to the ones that have like x k minus xi and this product of x j minus xk, and the same for L. So the one that has K and L in it, both in it, there's only one of those, yeah? Okay. That one's the one that gets negatived. There's only one of those, because either K is smaller than or bigger than L. It can't be both. Okay, if everything else, it just swaps to the other one. Okay, so V is alternating. So whenever you swap two variables, it goes negative, but otherwise unchanged. Okay, yeah. Okay, so so this is a better way to show it's canceling, because when you have an alternating polynomial and you sub in two things as the same, um, yeah, you should get 0. I think that's a pretty straightforward fact. So if you have a polynomial that's alternating, um, so yeah, f is actually the numerator, remember? So this is the numerator. And it's alternating. Okay, because g is symmetric and v is alternating. So when you swap two variables, g is unchanged and v goes to negative. So f goes to negative overall. Huh. So let's see. So if you take f and you sub in two things that are the same, then it should equal 0, purely because it's alternating. Why is that? This argument seems very strange. This is, hmm. Is it trying to claim that every alternating polynomial has a factor of xi minus xj? Hmm. Okay, so they're claiming that anytime you have an alternating polynomial, it has a factor of, so because if it's zero, it has a factor of xi minus xj. Okay, but if we conclude that it's zero only from the fact that it's alternating, then it's saying every alternating polynomial has a factor of xi minus xj. Hmm. Is that true? How do we conclude this? I think I understand how this works. So if you have like two spots, xi, xj, right? If you swap them, you get negative. Yeah, so this is not there, but we can figure this out ourselves. Xi. So if we swap them, you get like that, right? Okay. So if you swap them, you get the negative. But if you sub in, okay, then they're equal. They're both equal to minus f. So so something equal to its negative. It's the only thing equal to its negative is zero. Yeah. And if you sub it in, then by the factor theorem, this divides. Okay. Ah, so this is kind of a pretty slick way to conclude that it's a polynomial. Yeah, and then that observation that I made before with the fact that g is the same 1 on xi is equal to g of xi. If you substitute the reciprocals of all the variables, you get the same symmetric function back, or symmetric rational function. Um, yeah, interesting. You said shortlist from 1 to 6. Why leave out 7? What about 8 or 9? Anyway, so yeah, so once you have this, knowing it's a polynomial gives you that it's constant. Okay, and then I suggested a way for finding the constant. So the way I had of finding the constant was just let the variable, one of the variables be 1, and see that it's inductive. But they suggested other ways, so I'm wondering if you're interested in seeing what they suggest. Okay. Hmm. So, Oh, so the comment is interesting. Let's see. If we write out an explicit expression for f, that's the numerator, right? And to prove directly that f vanishes when xi equals xj for some I not equal to j. But no other pair of variables coincide. We have to check carefully that the two non-zero terms in the sum cancel. Ah, so that's what we did yesterday, okay? A different and slightly less convenient way to identify the constant is to substitute xi equals 1 plus epsilon times. That's strange. Hmm. Okay, let's have a look. How do I identify the constant according to them? Substitute xi equals this. Is it x? It's not xc. I know it's not xc. Is it psi? Maybe it's psi. It's a primitive nth root of unity. The psi, not the psi to the I. Okay, what's the point of doing that? In the ith term in the sum, in the original expression, we have a factor 1 minus psi I. Ooh. So in the ith term, the ith term is this thing here. Okay, so there's something where it's so j could equal n minus I. Okay. Okay, so sometimes j equals n minus I, unless, so this is unless n minus I equals I, right? Which makes n even, or possibly um, I is equal to n, in which case there's nothing, there's no zero there, so I equals n. Okay, so yeah, obviously if there is something with n minus I, then this to the I times that to the n minus I is equal to that to the n, which is 1, right? And so 1 minus that is 0, so the whole product is going to be 0. So the only terms which survive is when basically n equals 2i. So if n is even, so if n is even, then the two terms that survive uh, so n on 2 That survived plus, the nth term always survives. J is not equal to n, xn. So if it's odd, I think it's just the last term. If it's even, then it has two terms. Yeah. Yeah, okay. They should be subbed in, so it shouldn't be x's, but it should be x. It should be size. But I wrote x's. Um, size. Okay. Yeah, so they say the same as what? So when it's even, there's two terms. If it's odd, there's only one term. Okay, so let's evaluate these terms, shall we? So what are these terms? So this one is equal to the product. Okay, so it's 1 minus psi to the j plus n on 2 over psi to the n on 2 minus psi to the j. Well, one thing you can do is you could write this 1 as psi to the power of n, and then take an n on 2 out. So then you get product, and take the psi of n on 2 out, and then the other stuff cancels. So you get psi of n on 2. So there's no j's anymore. So you just got to power it up now. So it's the power of n minus 1. So it's psi to the power of n on 2 to the power of n minus 1. Huh. I did something wrong. To the n minus 1. What's the primitive nth root of unity? Times n minus 1 on 2. So confused. What? Did I do something wrong? Um, hmm. Psi of n on 2 seems like a perfect candidate to factor out. Okay, what about this thing? What's this one? Pi j is not equal to n. Psi of n is just 1, so this is just 1 minus j on 1 minus psi j, right? That's equal to 1. That's equal to 1 no matter what. I got that much. Okay, so that part is always 1. So this part is always 1, whether n is even or not. So if n is even, the other part should be minus 1. And if n is odd, the other part should be 0. Okay, so we already have that. When n is odd, the other part's 0. Okay, so it's just when it's even, the other part, yeah, the other part doesn't exist when it's odd. We just show when it's even, that part is equal to negative 1. Hmm. Yeah, I guess this is just showing this is equal to 1 or minus 1, yeah? So I guess it squares to 1, so it should be either 1 or minus 1, yeah? And it shouldn't be 1. I guess it shouldn't be 1, because then it wouldn't be primitive if that was 1. So if it was 1, then there'd be like this factor of n, which powers, like, yeah, it can't be 1. Because if it was 1, then the GCD of n and that would also power to 1. And that's contradicting its primitive, yeah? Okay. And obviously, it's not a multiple of n because n is co-prime with n minus 1, so it has to be a factor of n on 2, which is smaller than n, so it's a contradiction. Yeah, I don't know if it's necessary to get the constant like that. I thought we had a better way to get the constant. Are there any questions? Yeah, so in the other thing, we just basically do the thing in the comment, which is sub in xi and xj and show it equals 0. Yeah. Yeah, so okay, good.